Okay, I think let's get started. Yeah. Thanks everyone for joining. Over to you, Feroz. Yeah. On the Zoom.
Yeah. Okay. So binary search comes into our mind, right? Because given array is sorted, and then we have to find an element in a sorted array. So generally what we do is like we consider, like getting into mid and then checking if searching element is, like lesser or it is bigger. Based on what the middle element, right? We decide our criteria, and then we'll come to either on the left search, or search item will be on the left side or on the right side. So basically in each iteration, we are, like evaluating and eliminating as well half of the array, right? So how it works? Yeah, so this is what the algorithm, what it does is like the binary search iterative, this array, right? This function, it takes an array argument, and then there are two elements here, low and high. So usually you can take the first element as low, and the length of the array -1 is the high element because it started from the 0, and the item need to be searched. Yeah, please join. So item needs to be searched in that particular array. Okay. And now what we do is like we usually try to take position, right? The middle position of the array. So this is what we are doing here. What we are doing, we are adding low plus high, and then we are dividing that by 2 so that we can get a middle position, right? And then we always check that low is less than or equal to mid. Basically, the where we are going to get that right, because if in case high is, if you have only one element divided by 2 means it will not get anything, right? So in that case, this condition is required when we reach that stage where we don't have any elements left. There is only one element left, right? So, and then what you try to do is you try to search that middle element with the item. So it is something like this. Right. So you have array here, right? And there are some items here. Okay. And let's assume that 0, 1, 2, 3, 4, 5, 6 places are there, and some items here. And let's assume that you are searching for 9. Okay. So what is your search first criteria will be? You have to get the low and high, because basically what you're trying to do is you're trying to get how many number of elements are there. So that, and what is my start position and my end position. So your start position is 0 and your end position at 6, right? So when you divide it by 2, you will do. So basically you will get mid of the array. So this particular element you will get. Okay. And what you do, you try to fetch that element from the array. Let's assume that this is what your mid element. Okay. This mid, and try to compare with the searchable item. Searchable item is, what is our searchable item here? Is 9, right? So we try to compare with the 9. Right. So this element you are trying to compare with the 9. It is not, right? It is not. So what you do, and what you are checking here, it is bigger also, right? If it is bigger, what you do, your low you change from this to the mid element. Okay. Now your low will be changed to mid element. That is what the algorithm does here. You try to compare, and in case if you are exactly matching item, so you are returning that is the item you found. Or what you do, you check if the item is less than the array of mid. Okay. If item is less, but in our case, item is not less, right? Item is more. So what we do, our mid itself will make it to low. So mid +1. So you come here. Actually, mid is here. Basically, start from 0, right? So now what you do, you start mid from here. Okay. And what we do, mid +1, and high remains the same. High, earlier it was same high, right? So you are not going to change. And now what you have this as a new search criteria. New search criteria will be this much: 8, 9, and 12. This is let's say 16. Okay. 16. Okay. Now what you do, you again start searching. Again, same loop continues. You try to get low and high, and then try to add, and then get a mid of it. So let's assume that mid you got it here. Okay, so it is 4 by 2. So 2 elements 0, 1, 2. You will come here. Okay, so what you do? Again, same thing. Same loop continues. Item, what you got? It is less. So what happens this time? This time it comes here. High, yeah, high decreases. High comes to mid -1. So what was mid here? This one, right? So mid -1 is here, and low anyway is here. Now again, what you try to do, you continue the same thing. In this iteration, right? So it is basically 0 plus 1 divided by 2. 1 by 2 is nothing but it will, you will not get anything, but integer it is 0. So you will find here. So anyway, this is also not possible. So low and high both becomes here now. But this condition is low less than or equal to mid. So now we got less than or equal to mid. Less than or equal to mid. Why? Yeah, this is true, right? Because it can be equal also and it can less also. Again, you get and in this iteration you will get this particular condition and you will return the mid. So mid will be this position now. Okay. So this is how this binary search is simple one. It is still possible you can do with the recursion actually. So what you are doing, you are doing the same iteration, but in earlier case, right? In earlier slide, okay, in this particular slide, you are doing the same iteration. Only thing what you are doing, you are changing high and low based on the condition. So same thing you can do in recursion also. So what happens, right? Based on the condition, you can again call. But only thing is that your low and high pointers are now changing here. So you can see that mid minus 1 because it's there. And mid plus 1 to high. So the same thing will continue. And once you hit the exact item, right? So basically you're returning the mid. So this is what it changes. So it becomes a bit easier if you use the recursion. And what is the growth of this function? Log? N. Yeah, log n. Because every time you are making the array to be half, right? Okay.
This kind of when we try to do binary search suddenly we found that our low and high, right? It's going out of array.
Yeah, that you need to check the conditions actually. See, for writing any algorithm, right? First, you need to make sure what are your boundary conditions. So what is the lowest element and what is the highest element? Because array, anytime you can get the array out of index exception. Even if you are coming less than 0 or if you are exceeding the max element. So that condition you need to make sure. So this is the one condition. So if you check your conditions, right? So first condition, what we have low is greater than or equal to high. So basically we are not going beyond high, okay, or less than low, because this condition will prevent us because we are not crossing the boundary in either side. Second one, what we are doing, we are checking here in each iteration, right? You can see that we are checking item is less than array of mid. No, this is fine. Only this condition is basically preventing us from going up, like either side. So that part you need to check. And here also. So this also. When low, mid you are changing, right? Because you are deciding low, mid based on the condition. Correct? So that time also you need to take care that we are not, like crossovering one another. Okay. So moving on. So yeah. I think you could able to make out, right? It is big of login. Okay, I think I will not go in more detail. I think you people understood how the binary search works, right? Okay, so next could be like the questions what can come from here is like count occurrences in a sorted array. If you want to find a particular element and you want to know how many times that particular element has been found in that particular array, right? So how will you do this? How will you try to achieve this thing? You need to find out. Yeah.
Find the mid element. My mid element. I just look up left and right. If it's again, I'll just keep going more. Once I saw that this element is on it, then I stopped one of the boundaries, like let's say left, and then I'll keep moving right. And then I can count how many steps I moved from.
Let's assume that here, right? You hit this particular one here. You found this element 20.
Yes.
Now what you do? You move left or you move right?
I can go both at the same time, right? Otherwise I can go one by one also.
You cannot go at the same time, right? Because your pointers are low and high pointers are already changed.
Whenever I find the mid, okay, then I know that this is my element. So there will be chances as this side also it can be repeated. So just whatever on my right side, I will just say mid plus 1, and left I will say mid minus 1. So that is small error, like 3 elements, for example.
Yeah. So in that case,
you find a different element.
Yeah, three as a
because in a sorted array,
yeah,
until you find a different element,
correct.
You make an attempt that could be an element repeated.
Yeah, then in that case it will be go of n square.
Yeah.
Because first time you have to start with this and keep checking how many elements are from. Yeah, you can.
Not from left side, as long as
You find a higher,
the higher max
bigger element. But which is also.
Yeah, so basically, same binary search thing only you can apply. What you can do is you can try to find the middle element or the element which your key is. Okay, and then what you can do, now you got the middle, right? So you got the index of that element. So now with that index, what you try to do, you try to find out in how many left position that element can be found, or that element will not change. Means here you keep searching until you get here. So basically you will find that element, and again in the next iteration also you go and try to find out if there are any next element is coming. So that way also you can do. Okay. And again, same count number of zeros and ones in a sorted array. So here also same logic you can apply. Or basically you can go iterate in a for loop and then keep checking how many times, because sorted means zeros will come and then immediately the ones will come. So basically once you get that point right from where 0 to 1 is coming, so you can note, and then remaining elements are nothing but yeah.
When it's the sort of binary array, it is zeros and ones.
Zeros are ones only. That
is a binary array.
yes, it is binary array only.
That's it, right.
Okay. How will you search in if you have an infinite sorted array, but it is a sorted array, considering that it is a very infinite in the sense here is very, very large array, huge array. Yeah.
It is sorted, right?
Yeah, but it is sorted. Yeah, same thing. Binary search only you can do. Yeah, sorted array. Yeah, binary search is the best. Okay. So this is the logic. I think the same logic actually. What you are doing here is you are jumping instead of completely dividing array. You are jumping based on some condition I equal to I to the power 2. Yeah. So earlier what you are doing, you are dividing exactly half. Now what you are doing, you are trying to hop for a square. Okay. Find a pair in sorted array. So how will you find a particular pair? For example, here in this case, right? So what you need to do, you need to find, for example, this is not 29, actually it should be 28.
10 plus 19.
10 plus 19, that's what I thought. Summation of numbers.
Yeah, 10 plus 19, 29. Yeah, 29 plus. So in case, yeah, summation of the pair, this and this, the sum should be 29. Okay. And this should be 28, I guess.
28 should be false. Yeah.
No, 28 also you can make 8 plus 20. This number I wrote wrong. Okay. Let's assume that if it is just 9, right? In that case, you cannot make 29.
Correct.
So that case it is false. So
sum of any two elements, if it is making the
yes,
this
yes.
required sum,
then it is a pair. So how will you do that? How will you find a pair in sorted array?
2 pointers, one to the
Yes. Yeah. In basic style, what you can do is you can take two loops.
Take the difference,
Yeah.
and just try to see the difference.
Yeah, take 2 loops, start from this and keep adding next number.
and see
2 plus 6, 8. 8 is less than given out to 29, right? So you move to again to a 2 plus 8 less than 2 plus 10 less than 29. So like that you keep going until you find 2 items, right? And if this is not making anything, then you can directly jump. So another thing what he said, right? Like we can use the 2-pointer array, 2-pointer approach.
And here I think we can stop, right? Because the sorted array,
Yeah,
the sum is going beyond, then there's no point in continuing the rest of the elements. So the loop will stop.
right.
You should break it.
Yeah. So usually what we do, right? These people I keep coming.
Sorry about that. Who are the
Hello?
suddenly extra work for you?
1 minute I will add.
7:15.
ಹೇಳಿ ಮೇಡಮ್ ಹೆಸರೇನು?
Respect.
ಗಿರೀಶ್
So is also good.
ಶಿವಕುಮಾರ್.
10 minutes is not always possible. Maximum 5 minutes. We need to maximum. You have to be there 15 minutes earlier.
Yeah, anyone else?
Always.
ಒಬ್ನೇನಾ ಆಡ್ ಮಾಡಿದ್ದೀನಿ. Okay. So anyone has joined in the Zoom?
I only have 3 hours.
They want me to start video. I think video is already started.
Only thing,
Okay.
I think we are drawing something on the board and then we will see.
Yeah. Now
And probably no voice, we don't have a mic.
mic is not there. So that I think Mac is good.
Captures.
Mac is good in that case. So I think, are you able to see this part of the screen?
Yeah.
Right. Now it's fine, right? Okay. And the screen is also visible.
Yes.
Both are visible, right?
Here is in the screen.
Screen is visible there, right? Okay. So what we have is we have another approach like something called as 2-pointer. Okay. So let me just write down this array 16, 19, 20, and yeah, okay. So and the output should be what we are looking for. We are looking for pair of 29. The sum of the two pairs is 29.
Feroz, sorry, can you see somebody join? You are the host. I think couple of them are in the Zoom.
So you need to admit them. It doesn't even prompt me. It should prompt you.
How I can do that?
I think it should show you.
We can take the control. This one.
Create the reason.
Two people entered.
Yes. It's Satish was saying that couple of them are.
Sankaram. Yeah, I admitted both of them.
Okay. That's the thing.
Okay, sorry. Okay, so what we do, right, in 2-pointer approach, we start from 2 pointers. One is the low and one is the high. This is visible to you. 30.
No, not really, but
We can assume it.
Yeah. here we can see, but not on the Zoom video.
30, right? So from 2 you start and then high point. This is something called as low pointer and then high pointer.
You have to have.
So what you do, right? Yeah, you keep adding both the numbers like 2 plus 30. What is your output? 32. So once you realize the output is more,
Bigger.
right, bigger than your what you're looking for, then you can decrement the low pointer because it is sorted array, right?
High point.
Yeah, sorry, high pointer. You decrement the high pointer. Now high pointer is here. So again, do the same thing. 2 plus 20
22.
divided by 2. So it is, sorry, not divided by 2 plus 20 is 22. So in this case, the element is higher. So what you do, right? You increase the low pointer. So low pointer is now here. Now again, I add 2 plus 20, 26.
26.
26 means what I have to do? I have to increase the low pointer. Now I got 2 plus,
8.
yeah,
So 19 is missing
20.
in between.
sorry.
19 is missing. in
19 is
between.
missing.
So,
After 16.
Then maybe I will not get it. So in this case, 8 plus 20, right?
28.
Yeah, so it is 28. So still less, right? So I will come here. What I will do, 20 plus 10, 10 plus
30.
20 is 30. It is more. So this time I have to decrease the low point. Now in these two pair, right? 10 plus 19, I get the pair. In worst case scenario, let's assume that I'm looking for something where the pair is not possible, right? Let's assume 27 or something where the pair is not possible. So what happens is, right? You will reach to a place where your low and high both are pointing at the same position.
Yeah.
Okay.
Merge.
So basically, so what we have is we have a condition there that low and high cannot be the same, because if it is same means you met a position, you met a place where
Converge. They both merge.
yeah, you cannot go beyond that because there is no element existing. You cannot form a pair. Okay.
That should be the first condition to break the loop as well, right?
Yes.
From the loop. Yeah.
I think I have not written the code snippet, but the same thing is possible there as well.
Right.
So 2-pointer approach, triplet in a sort. You can find a triplet also using the same 2-pointer approach. Maybe you can try that. Okay, it is same thing only. First you find triplet means sum of three elements.
Some of three
Sum of three numbers.
Three elements
Yes.
should be there.
Yes.
But here the complexity will increase because we have to hold one.
Yeah, we have to hold one and keep doing the two things. So it is big of n square. Otherwise, it is big of n cube.
So what is the best approach? Like when I was go for interview, we have many things like a 2-pointer and research. So, like iterative. So what is the we have to what we need to think before writing the program? Or
Yeah.
just discuss the complexity first and then write.
No. I think I was mentioning in our earlier sessions also. First, you try to get the solution. Okay, with the pen and paper, you try to find a solution first, because that is what the examiner will be looking at. Are you able to solve the sum or not? Once you realize that, okay, this is the way I can solve the sum, right? Once it comes in your mind that, okay, I can solve the sum using pen and paper, I realize that sum can be solved. Now you think next, right? How I can improve this? Okay. For example, like if you are able to solve the sum using the normal binary search, right? Then you in the two for loops, you will understand, right? For loop is coming inside one more for loop. First for loop will iterate, and second for loop you are like going through the next element to find a match. So two for loop, definitely big of n square. Now you see if is there any better approach than big of n square. It is for you because you are spending with pen and paper. If there is any timeline, right, you have to finish in this time only, means you can definitely go with the big of n square if you're not finding any solution. But quickly, if you could able to make out, okay, I can go with the 2-pointer approach, okay, then you better spend some more time with the pen and paper, because writing program will not take time until unless you decided that what exactly I want to write. If you start opening your what is it, Eclipse or editor and start typing program, right, then definitely you will go wrong with the boundary conditions. Most of the time we have seen, right, if you're writing thread programs, illegal monitor state exception, definitely most of the people will get. So many people I have interviewed, right, they will end up there only, illegal monitor state, because they don't know which condition, when to wait and when to notify. Similarly, in this case also, you don't know where to check the condition, where to check the boundary condition. Okay, there only most of the things will go wrong. Either you will be too restrictive that some things you won't allow it to go. Sometimes you will just be left loose that it will go out of the like array size, or even come less than that. So definitely that is like you have to spend some time, understand the question first, try to solve with the pen and paper, and then go for the next how you can approach the this problem, right? So that makes sense. Okay.
Good question. Like the use cases might be suitable where we in the real time. Let's say triplet or a pair search.
Triplet.
This one, any Amazon coupon is, see here will merge some number. It's like Amazon also voucher or something, the 29 is there. You just pull the lever, 4, 5, 6, they will add with the 29 is there. Just a game type.
Not only game, even this captcha, if you see, right, captcha. Sometimes they will add this plus this number, what is
Government
the
websites.
IRCT, if you try to book the ticket, right, sometimes it will get confusing, minus will be there, sometimes plus will be there, like that.
Okay.
There will be
like something before random pickup something.
Yeah.
That's the one.
Yeah.
Any
Some
other
randomly
application?
they will take. Officially, I have not seen anything like this,
But
like
you
you want to find a pair, but it is generally interview kind of questions. Basically, they are trying to see how much you know the concept.
If there is a situation, how we tackle it?
Yeah, any situation like that.
That's a good question. Thanks, he asked. I really like it. Maybe as part of this, right? Within JDK, not many of us, probably while taking a sessions, we might open up some source code and see. But we would have this decent understanding than what most of us do. Within the JDK internals, if there is an opportunity, the library classes, you could also probably.
Yes, definitely. There are tons of algorithm being used in the JDK.
Okay, collections we might,
Yeah.
but if not.
Yes, collection is set actually, but inside that JDK code itself, a lot of algorithms have been used.
Got it.
So maybe I can demonstrate that. Like
I was actually thinking on the same lines. Where exactly you want the triplets and all, where it would be.
yes, yes. What is the decision behind taking this particular algorithm? So that you should understand first. Then you will tackle like in this particular situation what can be best suited. Like because we have so many algorithms, right? Best suited is not only based on the time complexity. Best suited is based on the kind of questions you get, right? So that is also important. Like what situation you are in and which is best suitable for you, like that. Okay.
Maybe encoding or whatever that encryption. Those places also maybe we can pick up and try to change the algorithm. Change the passcode or something.
Yes.
Right.
Here in this slide, as it mentioned, you can use 2-pointer approach irrespective of an array is sorted or not.
Yeah.
If array is sorted, obviously there are some presumptions we could make it positively. If it is not sorted, obviously it will go for a toss, right?
You can sort the array first.
That's exactly.
That is not confusing, right? Because examiner will ask, you will be thinking only with respect to, okay,
point is
not sorted array, how I will solve. You will say you sort with the, you use only 2-pointer approach and solve. Like that only he will tell.
Yeah.
And you will be thinking that, okay, how it is possible? Because if I have to increment and decrement. So this is tricky question.
Yeah.
First you sort it. No, who is stopping you to sort it first? You get the sorted array first. and then solve.
You need to make the sorting for me, that complication will be added. The problem.
That is fine. That is, he has not asked you to solve in big O of n, right?
Got
If he has asked, then you can cross check or you can think something different. Okay, if solution exists. But he has not asked you for, right?
Right.
Yeah. So that is a tricky kind of question what comes in the interviews, right? Okay, how will you do this? A square plus B square equal to C square. Same thing, right? Every item you are picking, you make a square of that and then add. Same thing, not.
Other probably a hypothetical.
Yeah, so-
question on this algorithm whenever you solve it, right?
Yeah.
You know, time complexity, space complexity, typically two different parameters.
Hmm.
Most often, I kind of see that time complexity wins over space, or what?
No, see there. Now the trend has changed like that. What you're talking, right? We generally don't talk on the space complexity.
Correct. It's
Space is not a like concern now.
Yes.
Only concern is the time.
Time.
Space is not a concern in Java word also because garbage collector is there. He will take
Correct.
care of that.
Correct.
Raghavan, I used to work in my earlier company LG, so I was working on set-top box.
Right.
Okay, so we used to have 128 MB of RAM. So you have to run all the programs in 128 MB of RAM only. Okay, not even more than that. That is the constraint. So now you cannot have some GBs and all. You cannot have.
Right.
You can think of even single integer declaration. You need to think one. What I can say, data type declaration also. You have to think why it is required. Okay, now that days are not there
Because
of the so much
always
of yes. Even CCTV camera is coming with the tera GBs nowadays.
Right.
You can store 6 months, 8 months, like one year data also you can store.
Storage is unlimited.
Storage is unlimited. Right.
similar to, I remember, as we were using DB2.
Hmm,
Before they
DB2.
migrated the code from C to Java. So version up to version 7, column name, any object, table name, column name should be restricted to maximum 8 characters.
8 is character. Yes.
So we had a tug of war in defining that prefix, what has to be there.
Right.
But maybe again, in any of this, where you think space complexity is very prominent and it swaps, rather we say, this is what is really internally, but timing is secondary. Is that something like
There are few systems, like for example, like this OpenJDK mailing thing you take, right? So you use any hi-fi things in your mail, right? Your body header and all, colorful and all. End of that, it will convert to ASCII only.
Right.
Because they have some storage restrictions.
restrictions?
Okay. So irrespective of 1,000 mails you send, no problem. They will accept it. But everything will be converted to ASCII only. So you cannot send some hi-fi diagrams and all. Whatever possible in ASCII, they will do in ASCII only.
Okay.
You might have seen that games, right? Hash, they will write and they will they will write name. So even if you want to draw a picture also, right, they will draw with some characters only.
Right.
So you cannot use hi-fi thing. ASCII 8 character things only you have to play around. Okay. Okay. Moving next. Okay, how insertion sort works. So insertion sort is basically comparison based sorting algorithm. Okay, I think I have few slides for that. Okay, so maybe things are clear here. After that, I will go to the algorithm. So for example, let's assume that what it does is like insertion sort. It considers array is sorted. Okay, first place. Whatever decision it is making, it decides that array is sorted. Let's take first element it has taken. So it thinks that, okay, 7 is sorted. And the right, it divides the array into two groups. One is left array and the right array. The first element, let's assume that 7 it is array. First element, chunk of set left set, which is sorted. And 2 from this array, right, it is kind of unsorted. Now you pick first element from the unsorted array and put it into a sorted array in this array. Okay, so for example, like this. 7, you declare it as a sorted array because you took first element, only one element is there, it is sorted. And the rightmost of array, right, it is unsorted array. And then pick first element from the right array and decide where to put. Okay, so insertion is based on the comparison. So it compares with this 7. Okay, based on where I have to put this item. I have to put before to 7 or after 7. Correct? So that decision will be decided based on the comparison. It compares and then it inserts. For example, it has to insert first. So 7 will be moved to the next position and 2 will be added here. So now what happens, right? So the left array has 2 elements now, which is sorted. And the right array, still whatever element is there, not bothered because it is unsorted. Now what I have to pick? I have to pick 8. Okay, next. And then again do the same thing, same comparison. 8 you are putting and then comparing with the 7. Okay, just to understand where I have to insert this. So this is what the insertions are. Try to remember. Once someone asks binary search, you know like how binary sort how works. But sometimes people get confused with the radical sort, insertion sort, and all so many things, right? So insertion sort is basically comparison related sort. It will decide where to insert that element. Just remember that where to insert. It will going to insert an element. How that insertion will happen? Insertion will happen because of you have one sorted array, unsorted array, and each element you are picking from the unsorted array and trying to insert that in a sorted array, right? So same thing here. So we can see, right? 8 is placed after 7, so there is no confusion. Now next, 5 will be picked from the unsorted array. It will be compared against 8. Okay, last element it is getting compared, and then 7. It is less than 7, so it will compare again with 2, right? So it has to come after 2. So the 7 will be moved 1 position. So the 8 also will be moved 1 position, and then your 5 will be placed here. Correct? And next again, so left array half of the size now covered, so it is sorted, and right side of the array is unsorted. Again, 1 will be picked and it is inserted here. So I'm just showing pictorially. Other elements are adjusted based on that. Okay, just remember that. Okay, even slides also moved very fast. Huh?
Just 2 times iteration, like first it starts, it puts the first element.
Yes.
It doesn't need to sort.
Yes.
It puts second element. If it is less than that, it puts in place. It says like done. Like the comparison always done on left hand side, nothing on right hand side.
No, right hand side is basically used for picking the element.
Pick the element.
Yes.
Left hand side is what we sort.
Yes. Yeah. Left hand side array is always like sorted array kind of thing.
That's why we.
Yes. Yes. So if you see the algorithm, right, algorithm is even simpler than this. Yeah, algorithm is much simpler. So what it is trying to do here, if you're trying to understand, right? So I am iterating in a 2 times I iterate. Okay, one is for the taking that element, taking left side array, right, making that left side array, and this is basically for the right side array. Okay, what I am doing here, first I will take in first iteration, right, key itself is the array of I. So that is my key, because that element I am picking where to insert the insertion element, and then I will decrement that, means I will start from that one position, right? And in this iteration, basically I was mentioning, right, that based on comparison, right, you are putting that element, and based on that the other elements index also need to be adjusted. So this is the notation for that. Okay, so that it will be inserted. So when I'm adding before 2, right, so the 7 will be moved 1 position this side. So that is what the position here. Okay, finally you found it, right? So you will here the placement is happening here. Once you move all elements and then one place left out, right? So that will be added. So this will continue.
So we started I equals to 1 because we know that 0th position is a sorted array.
Yeah, that is the first element I'm going to take.
Yeah.
Because here, right, I'm taking that.
Yeah,
Sorry, I minus. If you start from 0, right, then it will again throw array index out of bound exception, because you are going -1. I covered this. Okay, what is the best case and worst case complexities? Best case is big of n, because if let's assume that array is completely sorted, you no need to do that multiple comparisons. So you need to just insert one element next one. Just that I have to again go back. There was another while loop, right? So you will not enter into that while loop. So it is big of n. So worst case is like completely unsorted. So every element you have to compare and place at the first position. Correct? So it is big of n square. Okay. Okay, how merge sort work? Any idea?
Divide and conquer.
Yeah, divide and conquer. Right? Merge. Remember the name, that merge. Basically, you are trying to merge arrays, right? Before merging, you have to divide also. So don't forget that. So how the division work? Given an array, what it does, right? It tries to take half of, right, and then try to
Sort the 2 different.
yes, sort different, unless you find a position where it can be merged. For example, here, right? So if the sorting division started here, means you have 7 2 8 5 and one side 1 6 3 4. I have that, let's say. Okay, so it will be like this.
Yeah.
Correct?
Yeah.
Now you cannot declare this as sorted, correct? So you further divide that on both the sides, correct? Now still you cannot consider this as a sorted. You further divide that, where you will left out with only one element. So now you can compare and swap, correct? So you compare this and swap, basically compare and check whether they are already sorted or not. If they are not sorted, then you swap it. For example, here whatever was read, 2 will come here, 7 will go there. So you will have 2, 7. Similarly, here 5 will come here, 8 will go there. So you will have 5, 8. This anyway,
Already
no
sorted.
swapping is required already.
That's
This is also
sorted.
already, yeah, right? So they will go merge back to that from where they got divided, right? So they will get merged. Similarly, these two will be merged. That two will be merged, and finally they will merge to the main array. So this is what the merge sort. So basically, you are getting into merging. Okay.
It is odd.
Hmm.
Odd number of even after division. One of them will be having more.
Yeah, that is still fine.
Last saying, what if array is of odd numbers? It can
Yeah,
be evenly
so, yeah,
divided.
understood. So let's assume that here you have only 3, right?
Yeah.
So what happens? One side 1, 6 will go, one side only 3.
It will always be hanging.
3 is anyway sorted. So that will go and merge. When it is merging, right, that time that comparison will happen. So
Anyways,
this,
it will converge at one point in time, so I think that's a one half of the array. We'll get it.
we have to order pizza also. I'll pay for that for these people.
Okay, so,
For Domino's or somewhere you can order.
sure.
They have something called as 99 rupees one something single menu. I think we how many people are? 2, 3, 4,
1, 2, 3, 4.
11 people. In 1 hour it will deliver. You order 10 actually, considering someone joins, right? People are still coming.
Yeah, yeah. So,
I will pay for that. So just order it. Okay, this is how the merge sort work. And this is very simple one. You can use the recursion here. So basically what you are trying to do, you are trying to merge, you are trying to actually divide it. And then finally you are calling a merge. So basically, see the merge sort, basically you are again calling, this is merge sort, right? Sorry, I got confused. So basically, you are repeatedly calling this merge sort, and finally you are merging. Okay, so this is what the algorithm is. Merge sort, you will call this merge sort. Recursively, it will go, and finally, once both will over the place where it cannot be, it cannot be met this condition, right? They will merge. In the merge, I have to show the code how that merge will work. Yeah, this is the merge condition. This is the merge, right? Yeah. So basically, if you see, right, it is not that complex. If you try to understand, basically you are trying to compare two sides with the condition that you are not exceeding, right? And you will be left out with one element. That is for the last one, the down one. It's fine because only one element. Once you come one level up, right? So you have two elements, and it is like you will in the last iteration, right? You will get like half of the element. You have to compare and merge. So basically, it is comparison. Two arrays given, right? So this is also sometimes question asked, right? 2, 3.
So last element of the array versus first element of the array.
Yes, exactly. Something like 6, 1, 2, 3, like this is it, right? So basically you have to merge. Basically it is comparison. So you are comparing 2 and 6. 2 is greater. So what you do? You'll place after 2. Or either you can do this way, or you can search for the smaller element and then place at the 2 space. Place it here. So basically that logic I have written over. So I will be sharing the slides because so many things to cover. I cannot go through each iteration, but this is what it does. Basically, it compares two arrays and merge. Okay. And what is the time complexity?
We go and log
N log n, because yeah. So how will you find an inversion in a sorted array? Yeah, inversion means if let's assume that if you have a pair, for example, like what is a pair I have taken? 3 and 4, right? Forms an inversion when I is less than j and array of I is greater than array of j. The array of I is greater than array of j in the sense, right? So these two are not inverted. Okay. These two are inverted because the two elements, right? Two elements, it should be in the wrong place. For example, here, right? 4 and 1, if you take, these are not in basically these are a kind of place where it should have been other way around. Yeah, this is still fine, correct? This is not fine, so this is inverted. So you have to find a inversion in sorted array. If there is any inversion, you have to find it. In unsorted array, you will find that. That's for sure. So merge sort, using merge sort only you can do. Looks like that. Partitioning in an array. Pick an element and partition. Yeah, this is another algorithm, basically partitioning, and we have something called as Lumento partition. So I will share the slides. Okay. So these are all some trickier questions. So how you do a quick sort? Yeah, some pivot element you will take and then sort based on that pivot element. So if I have people are coming and joining in Zoom also.
Was it? Great.
I see Praveen joined. Saurabh.
Bubble sort is the simple one, right? You will have just to keep comparing. And this is the worst sorting algorithm because it's like we go of n square in best and worst case also. Okay. Even best case also, you have to keep comparing the last element.
Only problem is since we have a lot of sorting, very difficult to keep all the concept different.
Correct.
Sometimes it will merge.
Right.
How do we like remember these things? You don't use it in everyday program.
No, if you keep using that algorithm, no, you will remember. Practice only you have to. Then it is not that difficult.
Couple of sorts, so we have to remember down. And then,
Radix sort and all you don't need to remember actually. Yeah, in inbuilt functions also available in Java library like arrays.sort, collections.sort. So basically it sorts.
So which algorithm internally they are using? Quick sort or?
Yeah, that is what I was about to come to. So basically based on your array length and array size, based on that they will decide that algorithm. So it is like heuristic. What is the array length and array, how elements are like placed there. Based on that the sorting algorithm will be decided. I think merge sort is being not merge sort. I have not put that name. There is one more sorting algorithm. I'm not getting that name. Basically, they use that particular one. Quick. Sorry?
Heap.
No, not heap sort. Some sorting algorithm. I'll show you the code actually. Now I don't have
Is there
that.
any other scope remaining, like you can add one more sorting
You
algorithm?
can add if you have, like you can add if you can prove that your algorithm is better, then you can propose that. But we are in a kind of state, right? We were born very late. People have already done a lot of.
within these two, I mean, the second one is faster.
So it depends because if you are using collections, right? Collection sort that is very complicated on collection.
Collections.
Yeah, because collection you can have array list, you can have linked list, you can have doubly linked list, anything you can use and call sort because all are children of this collection. Yeah. Array is kind of simple based on data type, it will just sort. But collection sort is a bit complicated. Tree sort is there, all that things are. So how sorting works, basically we are comparing objects and then writing a logic so that swap and these things can work. Yeah, there are some standard you are familiar with Java, right? So we have compare to method, correct? And then we have compare method basically to you just need to this most of the exams it will be asked when you use compare to and when we will compare.
Comparable versus comparator.
Comparator. Yeah. Okay. How will you find kth smallest element? Kth smallest in the sense like, for example, a k is 2. So first small is this one, right? Second small element is here 2. For example, if I sort that, right? So you'll have 1, 2, 5, 6, and 7. The first smallest element is 1 and second smallest element is 2. correct? So if I given k equal to 2, that means you have to find kth smallest element. So output is 2 basically. What is the second smallest element in the array? So how will you do that?
Sort and index number minus one index.
We can,
That is also doable.
we can create a map actually. Each element will have some index.
Map. What is the
No, if you don't want to sort it, okay, we just take which is the smallest element, put it into the map, corresponding index is there, 0, 1, whatever. Right? And then whenever we create the map, whatever the element will do, k, 3, 4, just we go to the index and return the value of that.
Okay. Yeah, you can do that way, and you can even sort and
Sort
then
and-
take the, like k minus 1. Position of that element is nothing but your
Basically, also basically sorting.
it internally sorts, right? Okay. Basically, this is what I have, what have you mentioned? Okay, smallest element, some element of partition it does, and there are some better ways. So this actually you have to study how it does. So I will not get into more detail. Yeah, there is another part.
Partition and sorting, partition will like kind of sorting,
No, sorting is different, partition is different.
But we are taking some part.
dividing.
Dividing.
So which means like, less than number on left hand side, higher number on right hand side, right? So it's like sorted, right? Then afterwards, no, meaning of partition is for dividing. Then it comes, if you want this, sorry, just dividing.
I'll not get into this because I have not gone through it.
This looks-
Yes. So these are all standard problems. You can study it. Segregate. Yeah, it is like you have a positive and negative numbers. You have to segregate positive and negative numbers. Even segregate even and odd numbers. Okay. So basically, if you sort the array, right? So if you have two things to do when you have positive and negative numbers, once you sort right, all negative numbers will come one side, and all positive numbers will come on another side. So that way you can do. Even and odd elements, the same thing. Modulo of 2 operation you can use, and you can sort the even elements and odd elements. Similarly, segregate zeros and 1. Again, if you sort normally, zeros will come first and 1 will come later. Yeah. Okay, recursion. I think we briefly covered recursion, right? How the recursion works. People are still coming. Joining in Zoom actually now. Okay, where you will use recursion? I think anyway, I just showed this slide. Basically, we use dynamic programming and backtracking. Any idea what is backtracking?
When we let's say we are finding some number, maybe the pin problem or this kind of question, and we know that after that there is no more, so we have to just backtrack. Just come, since we have the recursion of the stack, we know where to come back.
Right. So for example, like if you are trying to find a shortest path, right? And in a shortest path, first whatever path you found now, you declare that as a shortest. For example, like this is a 1 position, you have to reach to 10 position. So there could be multiple routes available. These are all the values I'm putting. And you can go like this. So you have to find the shortest path. Let's assume that you went in this path and you found that this is the shortest. First you declare this is the shortest. First whatever path you found is the shortest. Now you are going through next path, right? Next path you are going through, and you realize here that, okay, I already till here, you have not reached the destination yet. Till this position, you realize that, okay, I have not reached the destination, but there is one better solution exists. So what I will do, I will not go next. I will backtrack, right? So basically I will backtrack to the position and I will consider this route is not going to work. So basically not this route actually, you will not backtrack completely. You backtrack only one position. So basically you come to this position and then try to see, okay, this will not work. So you try to go to the next and try to do that. That is basically backtracking, right? And even divide and conquer, we saw that in a merge sort, right? How division will happen and finally conquer will happen. Basically, you use recursion for that. And there are some standard algorithms, like tower of Tuna, right? that you have a three
Stacks in it.
yeah, three stacks. This problem also asks. Nowadays, people are not asking when we were like searching job, right? That time, this was very common problem. Tower of an eye, and you have one temporary bucket, and you have one this is a destination bucket, and this is a temporary bucket. So you have to copy all the elements from here to here, making sure that bigger only will sit down, correct? And you cannot place small element or big element on top of small elements, something like that. So this is only 2-3 lines we can solve, right? If you we have used to like mug up that one formula like that. Otherwise, it will be very difficult, correct? So there also a recursion comes in the picture. Yeah. Yeah, number 1, 2, and how will you print in recursion? We actually go from this is basically what we are trying to do. In this case,
We're going till whenever time becomes 0. Basically, not 0, like whatever the number we are putting. And
last.
last.
No, it is not like that. That is what the recursion is. You'll start printing from the first index only, 0 to n only you will put. But it looks like that. See what you are doing? You are always calling n minus 1.
We are going the reverse direction.
The print has not happened yet. Remember that. So first, let's assume that recursion, whenever you are solving any recursion sum, now try to take very small number.
This
Okay.
condition only creates that problem. Actually, when how to come back?
Yes. So let's assume that you have to print 1 to 5. Just take small example. 1, 2, 3, 4, 5 is output. You should print 1 to 5. So what you will pass here first? You will pass 5. Is not equal to 0 means not the last condition. Okay. So it went inside. It again recursively called print n minus 1. So 5 is there still, but I called print n. Okay. Again, I will come here. I will call print 3. So this is also called print 3 I called. So if you want to actually analyze, right? So you have to always consider the stack. Okay. So first what I call print 5. Correct. Print 5 got called. Okay. So first print 5 will not be there in the stack. So your program started. Okay. And print 5 is called here. And print 5 and then system.out.println is here there somewhere. So print 5 is calling print 4. Print 4 goes and sits inside the stacks now. Okay. My statement is still here only. Okay. So print 4 is called. Now print 4 will call print 3. Okay. Print 3 will call print 2. Print 1. And print 1 will call print 0. Okay. I have not reached here yet. Okay. In 0th condition, here, right, it just returns. Because n equal to 0 in this condition. It just returns. Once it returns, right, you come here. You come here in this stack. This stack, right? So in this stack, what you will print? Here, in -1 case, you have just returned. For 0, you have just returned. And return it has come back. And then what you are doing? You are just printing 1 here. Because the return happened, right? So you will print 1 here. So you have printed 1 here. So similarly, what you have printed here, you have printed 2 here. You have printed 3 here. You have printed 4 here. And then the call has went back to the main caller. So print 5. So by that time, you have printed 1, 2, 3, 4. Print 5 is call is over now. Now the remaining thing is that, print 5 is inside the function. So this print 4, you created the stack. And then system.out.println. Till here, you anyway executed stack. You finally prints 5 here. So this is how that recursion works. Okay, so this
change this out of before the print, it will print 1 to end to end.
it will print other way around. It will print from the back. Yeah.
In Java, like this kind of like stack overflow, we get when we do too much recursion. Is there any limit like only?
Yeah, 1024 is the limit.
1024.
102 per element is the limit. Otherwise, you will get stack overflow. Stack overflow. 1024 elements. Huh?
Even the latest versions,
Yes, 1000.
Java 1922. 1024 is it?
Sorry?
How much you allocate?
No.
The XMS you're talking about?
That is heap size actually.
Heap size?
That is heap size.
It's heap.
Looks like stack size is 1024.
1024 is the stack size. Default stack size of, see, there is something called as, if you remember, we have x-axis.
Yeah.
Okay, this is the stack size. This is default is 1024.
Oh, we can
We
tweak.
can configure actually.
Yeah.
Yeah, like XMX we do, right? Or XMS we do, we can configure this. So if you want, you can add 204 it. The problem here is that, see who will get the stack? Thread will get the stack, right? For example, like number of threads you create, right? So in native memory, it has also restricted. So if every thread is, we are giving 1 MB, 1024 is nothing but 1 MB, right? So sorry, 1 KB. 1 KB. And then again, that stack depth of the stack is 1 MB, 1 KB, but stack also has some size, right? So that also we consider as a 1 MB of each. So it is basically 1 MB is the threads. One thread, if you create, it will take 1 MB of space because it will allocate the stack. So if you increase that one, right? So your thread usage is, you are making 2 MB by default. If you have requirement, then only increase, otherwise don't increase.